In lesson 2.8, we're going to be graphing linear inequalities. So an inequality means we're going to be working with less than or greater than symbols, less than and equal to or greater than and equal to symbols. If you recall, when we work without an equal to, it will be dashed, and when we have the equal to bar, we're going to end up with solid lines. So the basic steps that we're going to use, we're going to identify the slope and the y-intercept to graph our equation, plot our points, connect our points using either dashed or solid lines, and then we have to shade all the possible solutions. Given y is greater than x plus 2, the first step is to determine our slope and our y-intercept. So our y-intercept is a positive 2. So we're going to go to our graph and plot that. Our slope is 1. So we could say 3 over 3 is 1, 1 over 1 is 1, 2 over 2 is 1. And sometimes it's just easier to graph rather than counting by ones, counting by perhaps something a little larger. So I'm going to go up 3. Rise over run, 1, 2, 3, over 3, 1, 2, 3. I can also make them both negative. A double negative means it's a positive, right? So now I'm going to go down 3, 1, 2, 3, over to the left 3, 1, 2, 3. And we're going to connect it with some kind of a line. So we plotted our points, and now we have to use a dashed or solid line. Because we don't have an equal to bar, we're going to be using a dashed line. It goes all the way through the graph. Next, we need to determine if we're going to shade above the dashed line or below. So we're going to take a test point from our graph. And since our dashed line is pretty far away from our origin, 0, 0 is a great one to use because it solves quickly. So we have our x and our y. Y is 0 greater than, our x is 0 plus 2. 0 is greater than 2. And we have to ask ourselves, is that true? It is not true, so we are not going to color in the below the line. We're going to shade everything that's above the dashed line. So we know any point that appears in the shaded area would be a solution. Now I wonder if a point that falls on that dashed line would be a solution. So we're going to take this point, which is 0, 2, and sub that into our original inequality. So 2 is greater than 0 plus 2. 2 is greater than 2. That is also not true. So any point that falls on the dashed line is not a solution because we do not have the equal to bar underneath that symbol. So only the values above the dashed line are solutions. Let's try another. So our first step says to identify the slope and the y-intercept. And in order to do that, we need to put it into slope-intercept form. Y equals mx plus b. So we're going to subtract x from both sides. So negative 2y is greater than or equal to negative x minus 6. Then we're going to divide everything by a negative 2. Divide everything by a negative 2. So y, negative divided by a negative is going to give me a positive 1/2 x, and a negative 6 divided by a negative 2 is a positive 3. And you can see I left the inequality space blank. So as a reminder, when we multiply both sides or divide both sides of an inequality by a negative, we need to reverse the inequality symbol. So this is actually going to be less than or equal to. So now we're going to plot our points, connect them, and then decide where we're going to shade. Okay, so we're going to start with our y-intercept of 3. We have our rise and our run. So it says to go up 1 over 2. I can go up 1 over another 2. Again, I could use a double negative. I could go down 1 and to the left 2, down 1, to the left 2, and then I'm going to connect these with a line, and I have to decide is it dashed or solid. And because I have my equal to bar, I am going to draw a solid line. The next step is to decide where we shade. So remember, we can use our test point of 0, 0. So we'll sub in our 0, 0 and see if it's a solution, and if it's not, we shade above. If it is, we shade below. So over to the left of the screen, I took my original inequality, I subbed in the origin 0, 0 for my x and y, and I ended up getting 0 is greater than or equal to negative 6, and that's true. 0 falls on the number line, it's greater than negative 6. So that means because 0, 0 was a solution, we would shade everything below the line. And I don't want to color over my 0, 0, so I'll kind of go around it. Then let's see what happens when we try the point 2, 4. 2, 4 falls right on the line, and this is a solid line. So I wonder if this one should be a solution or not. So let's test that. Okay, so again, I took my original inequality, I subbed in my y and my x, and I say y and x because the y value came first in the example, and we ended up getting negative 6 is greater than or equal to negative 6, and that is true. So that means, unlike the previous example on the other slide, when we have a solid line, all the points on this line are solutions, as well as everything that is below it. We have one more example, and it's going to be graphing absolute value inequalities. Our absolute value inequality steps are going to be a little bit different than the previous slides. We need to determine the vertex. Then we'll find the points, decide if it's solid or dashed, and then shade it. So we know that HK would be the vertex. So our vertex is going to be 3, 4, and we'll plot that. So we go over 3, up 4. Now we need to find some points. So we'll choose points for x and solve for y, plot those. So I want an x value that's going to fall to the left of my vertex, so I chose 1. So negative 2, and then 1 minus 3 is negative 2. The absolute value of negative 2 is a positive 2, and negative 2 times 2 is negative 4 plus 4, so y is equal to 0. So when x equals 1, y is equal to 0. And you'll notice that I put equal signs here since I was solving for y. Now I want a point that's going to fall to the right of my vertex. So I chose when x is equal to 5. So we end up with negative 2. 5 minus 3 is 2. The absolute value of 2 is just 2. So negative 4 plus 4, y equals 0. So my ordered pair here is 5, 0. And my other one was 1, 0. Then we decide if it's solid or dashed, and we have no equal to bar, so we are going to make it dashed. And then we have to decide if we're going to shade above or below. So we're going to use our tried and true origin 0, 0. So on the bottom of the screen I have that we're testing 0, 0. We put it into our absolute value inequality. We ended up getting -2 and the absolute value of -3. So we know that the absolute value of -3 is just 3. So that comes out to 0 is greater than -2 times 3 is -6. -6 plus 4 is -2. So 0 is greater than -2. That's true. So that means we want to highlight or color in everything that's above the dashed lines. And remember, points that fall on those dashed lines are not solutions.